So we're going to continue with part of the lesson. Now we're going to be covering the distance between 2 points on a real number line. So it's pretty basic, it's pretty simple. So these are the two formulas that you could use: the absolute value of a minus b, or the absolute value of b minus a. So let's say that they ask you to find the distance between, and that's what b/t stands, between -5 and 3. So let's go ahead and assign a value. We're going to say a is -5 and b is 3. Now, as you watch any of my videos, please pause. If I'm talking too fast, you get to pause the video, go ahead and write this in your spiral, your notebook, and then continue on and press play. So using the formula, we have the absolute value. We're going to substitute the value of a with -5 minus substituting the value of b, which is a -3. Well, -5 minus 3, since they're both negatives, then that becomes a -8. But we already talked about absolute value, and we said it's always going to be positive because of the distance. So the distance will be a +8. If we would have used b minus a, just to show you, it would have been 3 minus, but because the 5 is negative, we're going to put it in parentheses. Now please keep in mind that this here, a negative times a negative, becomes a positive. So we have 3 plus 5, which is an 8, and once again, the absolute value of 8 becomes an 8. So if you want to try one on your own, -12 and -3. So either one, whether you use the first one or the second one, so we're going to just say that a is -12 and b is a -3. So the first one says -12 minus the -3. So don't forget, because of that, we need to put the parentheses. So this becomes -12. That there becomes a +3. So this becomes the absolute value of a -9, which is just a +9. So the distance between those 2 points, it's 9 units. Now, the next part is going to be a lot of writing. More than anything, it's where we're explaining all the properties of real numbers, but there's a lot of properties. So I'm going to explain it, and if I explain it too fast, once again, pause the video, make sure everything goes on your notebooks and spirals. So the first one is called the commutative property of addition. Now, what does that mean? It means that you are allowed to change the order. And here's a very simple example. If 13 plus 7, is it the same thing as having 7 plus 13? It is. Now, what allows you to switch the order? The commutative property of addition. Another little sample. 5x plus 1 is the same thing as having 1 plus 5x. Once again, this is possible because of the commutative property of addition. Now we also have the commutative property of multiplication. This one also, all you're doing is changing the order, but while you're multiplying. So let's say I had the square root of 2 times the square root of 5. The same thing, it would be square root of 5 times the square root of 2. Or if I had x times 6, which is also the same thing as 6x. So So once again, for commutative, all you do is changing order, but it does not change the value. And this is the formula, it's a plus b equals b plus a. And for the multiplication, a times b equals b times a. So those are the first two of, I think there's 8. The next one is associative. The associative property of addition is the first one we're going to cover. So in this one, we change the grouping but it does not affect the sum. So we have a plus b in parentheses plus a c, which if we change the grouping, now we're going to be grouping b and c and adding the a, and it should give us exactly the same answer. So some examples, just so you could actually see it with values. If I had 3 plus parentheses 8 plus x, now can you combine the 8 and x? No. So the parentheses drops, and that 3 plus 8 just becomes 11 plus x. And if I were to do the associative property of addition, which is just changing the parentheses, grouping two other things, now I'm going to group the 3 and the 8. 3 plus 8 is 11. 11 plus x is still 11x. So both sides still give you the 11 plus x. So now the associative property of multiplication. In this one, we'll change the grouping when it does not affect the product. And the formula of this one is if you have a times b and then times c is the same thing as having a times b and c. So associative, you have to have a parentheses in there somewhere. So it's like having negative 2 times 3x, but then it also, the same thing if I were to group the negative 2 and 3 and have an x outside. Both of those would give me the same answer, which is a negative 6x. Next one, the distributive property of multiplication over addition. Now this one is just a fancy name. It's basically distributive. You've done it before. It's just we need to cover it. So when you multiply, I distribute over the addition. So basically, this is what it means right here. When anything outside of the parentheses, whether it's in front or in the back, you need to distribute to both things that are inside of the parentheses. So here's an example. So let's say we had 7 parentheses 4 plus the square root of 3. We need to make sure and we distribute the 7 to both of those things. That becomes 7 times 4 plus 7 times the square root of 3. The 7 and 4, we could simplify that, and that becomes a 28. But the 7 times the square root of 3, we can't do much, so it stays 7 square root of 3. In this case, that's as far as you could take that. Next one, the identity property of addition. So it says here 0 can be deleted. That means a plus 0 is a, and 0 plus a is a. So the 0 doesn't change anything, it doesn't do anything. It's an identity, so it stays the same. So an example would be the square root of 3 plus 0. Well, that's just square root of 3. 0 plus 6x is just 6x. So this is pretty basic information, but we do have to cover it. The identity property of multiplication now. So when we talk about multiplication, we need an identity. We don't use a 0. Here we use the number 1. Because anything times 1, it's that thing itself, that number. So a times 1 is a, or 1 times A is A. So the examples, 1 times pi should be pi. 13x times 1 is 13x. So I understand that I'm going really fast. Once again, pause this video. There's 2 more things, and then we're moving on into a different thing. So the last 2 are inverse properties. The inverse property of addition. So let me just go ahead and write all this out, and then we'll explain it right now. So when you hear the word inverse, think of reciprocal. Think of the opposite. So we are looking for the sum of a real number, and it's additive inverse, but it has to give you 0. So if I have A, how can I get rid of A? By subtracting A. So that's why we have A plus negative A. If I have a negative A, how can I get a 0? By adding A. So if I have $5, how do I get rid of the $5? By wasting them. And when you waste something, we subtract. So the little examples here would be the square root of 5. How do I make that a 0? By adding a negative square root of 5. And if I have a negative pi, how can I get rid of it? How does it become a 0? By adding a positive pi. If I have a 6x, how can I get rid of a 6x? By adding a negative 6x. If I have a negative 4y, how do I get rid of a negative 4y? By adding a positive 4y. All these give me 0. So those, you're looking for the reciprocals, the inverses, so you can get rid of them. Now the inverse property of multiplication. So here, because it's multiplication, we're looking for the product of a non-zero real number. And it's multiplication, or multiplicative, I can't even say it. Inverse gives you a 1. So A, what times A will give me a 1? Well, I need to multiply times the inverse. Remember, inverse means reciprocal. So that's A over 1. So the reciprocal of A here would be 1 over A. So A times 1 over A gives you 1, but we need to make sure that A is not 0. Now, if I had 1 over A times what gives me 1? Times A. Again, where A is not equal to 0. So some examples. I have a 7. What is the reciprocal of 7? 1 over 7. Is 7 times 1 over 7 1? Yes, it is. Let's say I had 1 over x minus 3. 1 times x over minus 3. If I multiply by x minus 3, then that right there becomes a 1. Now, when we say for it not to be equal to a number, the only reason we say this, like in this problem, if x is not equal to 3, what would happen if it is equal to 3? If it were equal to 3, that x were equal to 3, that would become 3 minus 3, and that would give you a 0 in your denominator. Is that allowed? Is it possible? Anytime you have a 0, it's undefined, so that's not good. So the way your assignment is going to look in reference to this, we're going to give you some examples. So what property are we using here? If I were to look at 11 times parentheses x plus 4 equals 11 times 7 and 11 times 4. So if you really look at it, what's happening here is they're using the distributive property. So then that would be your answer. The distributive property of multiplication over addition. So basically that's what it is. If you were to just put distributive, there's only one, I'm fine with it. Looking at this next problem, if we look at it, I see parentheses on both sides, and I'm thinking it might be associative. But remember, associative means you put the parentheses around different numbers. And if we look here, it's 2 over 3, 2 and 3, and over here still 2 and 3. So it can't be associative. So the other thing has nothing to do with an inverse. So it has to be commutative because we're just changing the order and it doesn't change the answer. 2 times 3 is the same thing as 3 times 2. So the answer here would be the commutative property of multiplication. The next one. So we have x plus 4 and then negative x plus 4. So what happens when you have a positive and a negative, and it's right there right on top? This becomes 0, and this is the inverse property of addition. So I know this was a lot of information, but it's nothing big. It's just a lot of work. It's a lot of writing. So one of the last things we're covering is simplifying algebraic expressions. Now this is a little bit faster. It goes easier. So let me give you a couple of seconds to write that down. So when we simplify, we need to understand just a couple of things. We're looking for terms. When I look at this, before I simplify, the question is, how many terms do we have? So when we look at this, there is 4 terms. Now, which are your 4 terms? Well, it is your 7x, your negative 9y, your q, and your negative 3. Those are the 4 terms here. Then another vocabulary word that you need to know what it is a coefficient. Now, a coefficient is a number that is in front of a variable. So we have 2 coefficients, or maybe we could consider 3, and I'll go over that right now. 7 is the leading coefficient of 7x, and negative 9 is the leading coefficient of negative 9y. But we could also say 1 is the leading coefficient of q, because there is a 1 up there. So in case you wanted to say that, that's another one right there. Now another little example about simplifying. When we're looking at 3x plus 7y minus 5x, we need to look for like terms. Now, like terms means that they have something in common, whether it's a variable, and an exponent, and then you simplify, you put them together. In this case, the 2 things that have something in common are the 3x and the negative 5x. So you should be able to combine these, add those. So what is 3x plus a negative 5? Different sign, so that becomes a negative 2x. The 7y doesn't combine with anything, so it just comes down. So just a little example here about simplifying. Let's say we had this problem. 6 parentheses 2x squared plus 4x, close parentheses, plus 10, open parentheses, 4x squared plus 3x, close parentheses. So we have 2 sets of parentheses. We have something in front of each one, so we need to distribute. So that's the first thing. What is 6 times 2x squared? 12x squared. What is 6 times 4x? 24x. What is 10 times 4x squared? That is a 40x squared. And what is a 10 times 3x? That is a 30x. Now when I look at this, I still should be able to combine like terms. In this case, the 12x squared and the 40x squared have both the same variable and same exponent. So you should be able to combine those with each other. 12 plus 40, 52x squared. Now when I look at the 24 and the 30, do they have a common variable? Yes, they do. So the 24x and the 30x become 54x. 4x. So that would be your final answer. So let's try this next one. Only because we have a negative number. So anytime you have a negative number outside, you still distribute, but you need to remember your rules. Negative 3 times the 4x becomes a negative 12x. A negative 3 times a negative 2y, because it's 2 negative, now becomes a positive 6y. And a negative 3 times 6, now that becomes a negative 18 plus 3x. So after you distribute, look to see if you could simplify. In this case, we could simplify the negative 12x and the 3x, which gives us a negative 9x. And everything else, we just bring it down. And there's one more last example. So let's simplify this one. So brackets, or it's like having another parenthesis. So we first need to work inside of this section. So what we need to do first is take care of that negative by distributing to the inside of the parentheses. So once I do that, nothing happens to the 8x, it comes right down. Nothing happens to that 2 for right now, so it comes down. Now, inside of those brackets, the only thing that happens right now, that 5 stays the same, but that negative times x, because it's positive, now becomes a negative x. And a negative times a negative 3 now becomes a positive 3. Now, I'm going to look inside of those brackets, and I'm going to see, can I combine anything? And by looking at it, I could see that 5 and 3 could be combined. So everything stays the same. The only thing is I'm working with the inside. That becomes 8 minus x. Once again, brackets are the same thing as a parenthesis. So now I have to see that I have to distribute those two. The 8x, I still haven't done anything to it. It comes down. 2 times 8 is 16. And 2 times a negative x is a negative 2x. So now I want to combine like terms. So the only terms that I can combine are the 8 and the 2x, giving me a 6x plus 16. So this is the end of this. I know the video is pretty long. Please watch it. Your first homework assignment is really copying. You're going to have a couple of problems. I'm going to send you a picture of what your problems are going to look like. And thank you for watching.